Dear students, today we are going to solve chapter number 9, sequence and series. Sequence and series carries 9 marks. Sequence and series se mark mapal lay ko. Kung sequence and series se define tawdringi da we consider the sum arrangement of numbers. Numbers kara har arrange taw basi yang si ko. Number 1, 1, 2, 3, 4, 5. Number 2, 1, 5, 7, 9, 11. Third, the 2, 4, 6, 8. And fourth, the 2, 9, 11, 17. And the fifth one, 1, 3, 5, 7. Harus main tawraga. Nangon the arrangement of numbers kara pireba. Number 1 gise 1, 2, 3, 4, 5 ni ko. Kya khenai number sing se amamong khenadra. Second gise na 1, 5, 7, 9, 11. 1, 5, 7, 11 and 9 ni ko. To this sigi difference kya lay 4 lay re. Sigi difference na 2 ni. Sina 2 tare sina mutu arrangement se nang particular oidre ba mamangi study 1, 1, 1, 1 khena raga chali ko. Aduga home subakis da mugi ngasi 2, 4 habis da kya khenai ani. Sisu ani khena re. Sisu ani khena re ko. Aduga mari subakis da yeng si 2, 9 habis da 7 khena re. Sidana 2 khenare, sidana mu kya khenare 6 sumain tawraga leire ko. Aduga number 5 kisina 1 ga 3 ga se 2 ne, 3 ga 5 ka se 5 ga 7 ga da 2 natra. Sumaina differencing se koina differencing se sum yengba kanda ahanba ge arrangement sing se na 1 1 khenare. Ani subagi si particular am leire ko. Number 3 gi se kya khenare 2 2 khenare. Ahum subagi sina 7 to 6 and mari subagi sina 2 2 khenare ba. Koina sequence command define tawrakani hardi. Sequence is the arrangement of the numbers in a specific order. Magi order natraga rule follow tawraga chatliba arrangement of numbers sequence haibane. Ahanbagi sima sequence tare ko amaramdi nangi number sing se previous one the plus 1 8 tawraga fange. Second gi se sequence natre, third gi se sequence tare ko. Nangi number sing se kya khenai. The difference between any two numbers of is arrangement of number is 2 tare ko. Si sequence oibra oidre. Aduga mga subagi se mok sequence tare ko. Kamaina sequence orino nangi number sing se previous one si the plus 2 hapaga koina semba ngammeba. Then a sequence kamain define tawne. Now we're going to define the term sequence. Sequence is an arrangement of the numbers or objects in a specific order. A sequence is an arrangement. Nangi sequence sabadi or a number natraga objects arrange tawbani ko. Karamba ways they arrange tawba in a specific order. Nangi particular rules natraga order amada follow tawraga chatlagadi arrangement of numbers or objects is called a sequence. Examples 1, 3, 5, 7. The set of odd numbers 2, 4, 8, 16. Si kamay na fange. First time si the 2 na multiply to the 4, 4 the 2 na multiply to the 8, 8 the 2 na multiply to the 16 tayo ko. And these numbers are arranged by multiplying the previous one by the constant 2. Previous time sing si the constant 2 amana so multiply to the number sing si arranged to. Number 3, the A1, A2, A3, AN is a sequence of oiragadi. If A1, A2, A3, AN is a sequence, then A1 is called first term, A2 is called second term, A3 is called third term, and the AN is called the nth or general term of the sequence. Example, the general term of the sequence AK is equal to K plus 1. Nangi sequence of iba the changiba rule singse. AK na denote tawragadi. AK se kamaina pire K plus 1 se oiba matamda. Nangi sequence se kamaina generate tawni habasi yengsi ko. Putting K is equal to 1, 2, 3, dot, dot, n. Nangi 1 amuk thame, 2 amuk thame, 3 amuk thame, 4 amuk thame. Last n thame ko. Then we get kai phangani. K se 1 thamadi A1 phangi. Putting K is equal to 1 in this general equation, we get 1 plus 1, 2. K is equal to 2, we get A2, 3. K is equal to 3, we get A3 is equal to 4. And proceeding in the same manner, we can write AN by putting K is equal to 2. If K is equal to N, K sina N thamaga dikhun AN se puthokpa ngamdoine ko. AN putho N plus 1 taradra. Duna K sida 1, 2, 3 sinba matamda A1, A2, A3 habise dum lakani. Si lakpa maramna sequence kaino sequence a function namne. So sequence is a function whose domain is the set of natural numbers and whose range is the set elements is the set niko consists of elements A1, A2, A3, A and dot dot. Infinite or the infinite oisagrani finite or gana finite or niba. Sequence haibase function namani. Function sigi domain sing se kai oigadaba natural numbers na to oigadaba 1, 2, 3, 4, 5, 6, 7 put tawpa matamda akoina phangdu se A1 phangni, A2, A3, A4, A5, A6 and dot dot mayam leigidoine ko. A duna K duna 1 oiba kanda A1 da map tawniba. 2 sina A2 da map tawre ko 3 sina A3 da map tawre 4 sina A4 da map tawni sumaina nangi se sequence ama haiba se function amneba ko magi domain sina natural numbers ni aduga range sina set of real numbers ni set of real numbers se kaina pirakani A1 A2 A3 A1 A2 A3 sidi nangi rule du ne general rule or general term of the sequence to aduna pirakadabani ko. Next topic, types of sequence. Sequence e makhala ni lai ko finite sequence haiba maga infinite sequence haiba maga. Finite sequence aidi kaino kaina sida sequence ampiriba sequence 1 3 5 7 haire ko sigi sida sequence sida magi sigi number singse. The numbers in a sequence are called terms of the sequence I cause the yariba numbers singse. The members or numbers in a sequence are called terms of the sequence in the first term, second term, third term, fourth term. Sumaina mathang lakadoine. Types of sequence. The finite sequence defined Taurasi. A sequence is called a finite sequence if it has finite number of terms. Nangi terms ya masing thiba ngam taraga the finite sequence ko example 1 3 5 9 99 pire ko 1 3 5 99 sida khoi last term se khangba ngam medana duna ma se finite sequence ko re number 2 2 4 6 10 100 2 4 6 100 lai masi su masing thiba ngamba oigadoine ko kaigino haradi nang last term pi. Number 2, the infinite sequence. A sequence is called an infinite sequence if it has infinite number of terms. If its terms are uncountable, nangi terms singse masing thiba ngamda taragadi koina infinite sequence kawe. Example 1 3 5 7 se infinite the ige haitar the 3 dots iragadaba. This 3 dot represents the sequence has infinite number of terms. Number 2 2 4 6 8 dot dot 3 dots singsena infinite sequence represent tawduiniko. Next, we are going to learn about the topic series. Series I say kaino define tausiko. Let A1, A2, A3, AN be a given sequence, then the expression. Nang si sequence maneba. Sequence the yaruba terms mayamgi sum se. Then the expression of sum of terms of a sequence, that is A1 plus A2 plus A3 plus dot dot AN. Nangis the yaruba term mayam se loina plus taw taragadi. Sigi expression je kai kawe haiba. Sigi expression je series kaweko that is called a series associated with a given sequence. Sequence amada associate tawba series tune. Nangi sequence ina finite already series to finite tare. If the sequence is an infinite sequence, then the series will be infinite. Sequence that depend tawduni ko A1 plus A2 plus AN. This expression can be expressed as AK. K be rise from 1 to kay harakani se n harakadaba ko. Nangi last term si n ni dana adun k be rise from 1 to kay dasat kani n da chatle ko 1 to n. Number 2 dana A1 plus A2 plus AN dot 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 haragadi infinite case neba. Infinite already a k iro aduga k be rise from 1 to kay lakani infinity. Ahan bagi sina n anisu bagi sina infinity tani ko. Sina finite ki second gi sina infinite ki. Next we are going to define Fibonacci sequence. Fibonacci sequence se kaino yang siko. The Fibonacci sequence is defined by first term, second term, A1, A2 is equal to 1 and the general term of the sequence AN is given by AN minus 1 plus AN minus 2 where n is greater than 2. That is, the general term of a sequence are generated by minus generator way by adding the previous two terms. Nangi hek mathakta lairiba previous two terms anise plus tauraga nangi term singse generate tawba oitaragadi aduguma sequence to Fibonacci sequence kawiko. A1 se 1 tare, A2 se 1 tare ko adudi 1 1 thamo. The third term of the sequence is obtained by adding A1 plus A2. A1 gi A2 ga plus taurakan phangneba 1 plus 1 2 taradra. 1 ga 2 ga plus tauradi 3. 2 ga 3 ga plus already 5, 3 ga 5 ga plus already 8 sumaina. Nangi hek mathakta lairiba term ani se plus tauraga sum nangi terms of the sequence generate tawba oiragadi sigi sequence maming kai kore Fibonacci sequence kawe ko. Mathangda koina exercise 9.1 sayings. Exercise 9.1, write the first 5 terms of the sequence and whose nth terms are given. Nangi nth term or general term set on pireba ko. Aduga ahanba term mga ito o ahanba term mga haitardi nang hozi n gi value sa kya thamgani 1 2 3 4 5 se thamduini ko. Here general term of the sequence an is equal to n divided by n plus 1. Question number 2 gini ko. Putting n is equal to 1, 2, 3, 4, and 5 successively in equation number 1. 1 the half ko. We get a1. 1 by 2 tare. 1 1 tham tare di 1 divided by 1 plus 1. 1 by 2 phange ko. Add a2. 2 by 3 a3 sina. 3 by 4 a4 sina. 4 by 5 a5 sina kya tare. 5 by 6 a1 a2 a3 a4 a5 kaino. The first 5 terms of the sequence oidoini ko. Next question. Next topic akoina makha tana tamduse kaino arithmetic progression important ni ko. Arithmetic progression haiba topic se important ni. A sequence a1 a2 a3 an dot dot is called an arithmetic sequence or arithmetic progression if an plus 1 minus an is equal to d. An plus 1 minus an is equal to d means nangi hek tam thangnaba sigi hek thangnaba term anigi difference always constant oigadaba ko, where small n belongs to natural number n, where a1 is called the first term and the constant term d is called constant term d is called the common difference of the arithmetic progression. Nang a1 sina first term kaure aduga d sina kai kaure common difference kawe ko. Hek thangnaba term ani se dum difference taba chap manaba constant amaga managadaba. Sina first term ni, second term ni, third term ni, fourth term ni ko. 7 dagi 2 5 khaido pasi 2. 9 dagi 7 khaido adi 2. 11 minus 9 is equal to 2. 13 minus 11 so plus 2 natra. Habadi hek thangnaba term ani gi differencing se chap manaba constant am ta taragadi. That sequence is called arithmetic progression. Arithmetic progression habase kai haraga sukhange. Arithmetic progression is a sequence whose terms are generated by adding a constant d to the previous term. Nangi hek thangnaba term se chida ahanbagi term sida constant d amasum plus tauraga generate tawbo oiragadi nangi sequence arithmetic progression ama kawweba ko. Habadi si 5 natra 5 to 2 hapsiladi 7 7 to 2 hapsiladi 9 9 to 2 hapsiladi 11 da muk 2 hapadi 13 sumain tawraga nangi term sing se generate tawbo yai ko. Aduna si arithmetic progression amani. Mathangi sequence yang si ko minus 2 da minus 1 hapadi minus 3 minus 3 plus minus 1 minus 4 minus 4 plus minus 5 tare ko. Asisuna arithmetic progression amani. Common difference kya oiba minus 1 oiba. Mathaki common difference na plus 2 oiba ko. If a is the first term and d is the common difference of the AP, then the arithmetic progression is the terms of the AP is equal to ahanba gisina a tarani, second gisina a plus d, third gise a plus 2d, mathang gisina a plus 3d. Sumain tawraga nangi terms singsa generate tawba yani heba. Ahanba terms the common difference d se sum plus tawgani ko. Next, we are going to learn general term of an arithmetic progression. Important topic ni ko. Nangi arithmetic progression amagi general term kamaina puthokadoino haiba. Let a be the first term and d be the common difference of the AP. And let a n denote the nth term or general term. General term si nth term sina denote tawgani ko of the arithmetic progression. Then the AP is nang a sina first term oraba, d sina common difference oitar the terms of the AP se kai tagani a plus d, a plus 2 times of d, a plus 3d, and so on. Sumain ibiyare ko. And therefore a1 first term of the sequence is equal to a. Duga nangi second term se kai oigani. Second term se a plus d tare ko. Third term is a plus 2d. A4 is equal to a plus 3d. Sumaina laeva. Sigi a1 se kaigi maong de express tawba yai. A1 plus 1 minus 1d. Sta thamba yai ko 1 minus 1 se 0 sale. And a2 can be expressed as a plus n minus 1d. And third ki a3 can be expressed as 3 minus 1d. See d se 2 minus 1d se d tai ko. Dugas 2d se 3 minus 1d se 2d ka manaydana. Sumaina. And to this is the 1 layer. This the 1 la ani. 2 layer this the 2 la ani. 3 layer the 3 la. 4 layer the 4 la ko. Sumaina tawraga. Proceeding in the same manner, we can write the general term or nth term of the sequence which is equal to a plus kay gamanagadaba n minus 1d si taagreba. A plus n minus 1d sinang by heart tare ko. Which is the general or nth term of a arithmetic progression. A plus n minus 1d sida a sina first term kawi, d sina kay kawi, common difference kawi ko. Next topic is sum to first n terms of an arithmetic progression. Nangi arithmetic progression amada yauriba n terms ki sum putokpagi expression ne. Is an important topic ni ko. Let A be the first term and D be the common difference of an AP. Let L be the nth term of the AP and Sn denotes the sum of the first n terms of the AP. Nangi arithmetic progression amagi first term sin A tare, common difference in D ore ko, and let L be the nth term of the AP. Nangi L se nangi last term ne, last term se nth term gi ohelle ko. L be the nth term of the AP and Sn denotes the sum of the first n terms of the AP, and so this Sn will be equal to A1 plus A2 plus A3 plus dot dot An minus 1 plus An. Have the sum of the first n terms se koina Sn sina denote tawre ko. A1 haitardi A ni ko. A2 already A plus D. A3 already A plus 2 times of D. And proceeding in the same manner, we can write An. An se ngasai L tagidra. Do the second last term se kaiga manabam to L minus D tabam to ko. Sibaw the nang equation number 1 taro. And rewriting the terms of equation number 1 in reverse order. Reverse order means first term becomes last term. Second term becomes second last term. And onthok na reba. First ka last ka se koina onthok na ba matam da we get Sn is equal to L. Matang the L minus D tare ko. Si ma'am si so onthok na resi. A plus 2D plus A plus D plus last term se A tare. Sina equation 1, equation 2. Equation 1 consists of n terms. Equation 2 so n terms consists of we ko. Ani si A tare se. Now adding equation number 1 and equation number 2 we get Sn plus Sn. 2 times of Sn tare ko. A plus L plus mathang da kaila kani. A plus A da L am hape ko. A plus D siga L minus D ga plus tawgadab. Corresponding term singsa plus taw receive. A plus D L minus D C plus D minus D cancel tawradi. A plus L tare ko. Dugi L minus D siga A plus D ga plus tawu matam da minus D D ka adi A plus L. L da A hapsiladi A plus L. Sumain tawraga A plus L ngakta phangiba nangi term singse. Term kya yaugani n terms yauduni ko. N terms yaure, then Sn will be equal to n multiplied by A plus L. Sitare ko. Then find Sn. Sn is given by n divided by 2 A plus L, where A is the first term, L is the last term of the sequence, and n is the number of terms of the sequence. Sige, Sn is equal to n by 2 A plus L. Habis na mentor se kaino. N sina nangi number of terms to neba. 5, 6, so nangna 5 number of terms 5 ki sum pa amadi 5 oitare. 6 ki sum pa amadi 6 itare ko. A sina first term of the sequence ni, L sina last term of the sequence ni ba. Si karam kanda use tawgani. This formula is to be used for finite sequence. Finite or kan use tawgadaba ko. And we know that this L denote the nth term of the sequence, and so this L is replaced by An. Then write the formula of An. An means the general term of the arithmetic progression. A plus n minus 1 d tare ko. A plus toro. 2 times of A plus n minus 1 d taradra. Nangi Sn se amuka su kamaina iba. Sn can be expressed as n by 2 times of A plus n minus 1 d. And this formula is to be used for infinite. Ani sinang bahar tawgadam ni ko. N by 2 A plus L haiba maga n by 2 times of A plus n minus 1 d. Sumain tawraga nangi sum of first n terms of the sequence puthok payare ko. Mathanga koina kaidawni exercise 9.2 gi question 1 se yengsi ko. Find the sum of odd numbers from 1 to 2001. 1 dagina 2001 bawgi marakta leiriba odd numbers mayam se asigi sum putho o haiba. In a sequence an is ko. Now write the sequence of odd numbers from 1 to 2001. That is 1, 3, 5, 2001 tare ko. Sequence sama puthokpa matamda first term puthokpa changi, common difference puthokpa changi ko. And the first term A1 is equal to 1, A2 is equal to 3, and common difference D is given by second term minus first term. A2 dagi A1 kaido 3 minus 1 plus 2 tare ko. Let An sigi marak se term kya yawi haba puthokpam changi ba. Now we are going to determine the number of terms of this sequence, and for this let us assume that 2001 is the general term or nth term of the sequence, and An is equal to 2001. Then write the formula of An. A plus n minus 1 d is equal to 2001. substitute A, first term of the sequence is equal to 1 n minus 1 d लेरेको and d की value से क्या हाप तारे plus 2 हापे 2001 तारे यदि 1 से transpose तो ग्रे को 2001 minus 1 is equal to 2000 n minus 1 into 2 2000 ने dividing both sides by 2 2 ना divide तो ग्रो n minus 1 is equal to 1000 and value of n is equal to 100 minus 1 transpose to d plus 1 tare ko 100 fange 1 dagina 2001 bawgi marks da yawa number of terms ya hojik 101 fange ko adudi 101 number of terms 101 si sum puthoke haitardi s1001 sida p giba final sequence ne use taw tare nangi first term na 1 ni last term sina 2001 tare ko S1001 is given by 1001 divided by 2 and A plus L. A sina first term ni L duna kaino L sina nangi last term duni ko 1001 divided by 2 into 1 plus 2001 ani se plus to baganda 2002 tare chige 2002 da 2 na divide to radi 1001 phangba ngame ko and the product of 1001 and 1001 is equal to 100201 chumai taraga koina kai puthokpa ngame we can find the sum of odd numbers from 1 dagina kai bogi marakta leba 2001 for today let's end here.